But let me just record this and show this part here. This. So check the morning recording for that. To conserve sodium hydroxide, so we don't run out, go to the low side. Be closer to the 20% below. And this is not a strict window. If you're less than or more than 20% off, don't worry about it. Just get something in that range. Try not to if you go over too big, then you're going to have to refill the burette. And you have the potential of running out of sodium hydroxide. All right, so you're going to have the target mass, and then you're going to have an unknown number. Make sure you write your unknown number in your lab notebook. If you don't put an unknown number, I have to take the maximum points off if I don't know. The maximum points off would be a hit. So, and then the final thing you need to know is, since this is unknown acid, we need to know, is it monoprotic or diprotic? And so all this information you need to know. So we're going to weigh out 3 or more samples and then titrate it. But in the part 1, we always got the same amount of acid, 25 milliliters. Are you going to get or try to get the same amount of acid this time? Let's say the first sample I weighed out was 0.08365. Are you going to work really hard to get the next sample to weigh that much? No. So what we're going to do is we're not going to use volume. We want a minimum of 3 titrations. So, we want 3 titrations with a percent difference less than 1%. So here you have a little bit more leeway. In part 1 it was 0.5%. In part 2 it was a full 1%, with a percent difference of less than 1%. But since we didn't use the same amount of acid for each trial, we're not going to use the volume. Instead, we're going to use the volume to mass ratio. The volume to mass ratio should always be the same for all these. I mean, if you start with the exact same mass, we should get the exact same volume in each of these runs. Since we didn't start off with the exact same mass, then we're going to calculate the volume to mass ratio. And the percent difference here is going to equal the biggest volume to mass ratio minus the smallest volume to mass ratio divided by the smallest times 100%. All right, this is going to save us some time. We're not going to do all the calculations in the lab, so this is a quick way to check if your percent difference is within the 1%. If it's more than 1%, then keep doing more titrations until you get it. If you do a 4th titration, throw out the worst one. If you do a 5th titration, throw out the worst 2. Just pick the 3 best ones. Okay. If you're starting to do a 5th titration, then we have to start worrying. So if you're at risk of running out of sodium hydroxide, then we might go to a smaller sample size. So rather than doing 0.1, we might drop it to 0.05, That way we use a lot less sodium hydroxide in the trials. So that's if you're at risk of running out. Because if you run out of the sodium hydroxide and you have to make new sodium hydroxide, you'll have to re-standardize the new sodium hydroxide using procedure part 1. So you'd have to repeat part 1 in order to complete part 2. All right, does that make sense? And so that's it. So that's all I want to say today. And then check out your stuff out at the stockroom window, and go ahead and get started.